Hello, welcome back to my channel again, Dwepute. I have been getting a lot of feedback regarding my previous video which I did on Kulaka in Sinhala medium. Some of the inquiries were regarding the content to be presented in English medium too. So I thought it would be beneficial for those who are learning in English medium to follow some video lessons to learn this. So there will be a series of videos in English medium. But for now, I thought to make this video, this exactly the same content that I covered in English. And this will be much quicker if you looked at that video or if you went through that one. Even if you didn't, and if you need more clarification on things that I'm going to discuss now, please get back to me. I'm happy to work those through. So let's get the work started. So we're going to look at the sets today. The learning intention is understanding sets, set notation, set builder method, solving problems using Venn diagrams. Let's have a look at our first example here. Let's read that one. Okay, here we have A, B, the sets of all multiples of 4 between 1 and 15. So we can write down this in words, just simply saying A, B, the set of all multiples of 4 between 1 and 15. So we can say A equals set of (1 and 15). Or we can simply list them. So we can list these. We know the multiples of 4 between 1 and 15, 4, 8 and 12. Or we can use a diagram to show this. We simply use a circle here. So we can simply write down 4, 8 and 12 in there. So that's our set notation. Let's have a look at our set builder method in line with the same example. How do we write that? Well, if I say A be my set, I'm going to use a letter here which will be a variable. So that's X, and then with the 2 dots, the colon, we call it such that. So we're going to tell what values X could take. So simply, it's X is a multiple of 4. And also, we know that X is between 1 and 15. We have to give that rule, otherwise we would not know where to stop. So that's our set builder method. Let's say this is our example number 1. I'm going to discuss another one. Let's say example number 2. We've been given, let's say, 2 numbers 2 and 3. How would we write this? Well, we can say this is exactly same as, let's say, y such that the y satisfy this condition, y minus 2, y minus 3. The product is equal to 0. If you use the null factor law, you would know that it's only y equals 2 and y equals 3 are the answers, which are the values given here. Or else, we can write down this again. We can say, let's say m. M is an integer, or rather you can call it another natural number. You can use either. Let me take integers. M is an integer and is between, I have to give the condition where the m is. Okay, m is between, I can say because it's 2 and 3, 1 and 4 is strict. Less than or equals in here, which means it cannot take 1 and 4. Any other integer would be 2 and 3. So we're done with that. Now let's move on to regions in Venn diagrams. We are going to have a look at what are the regions in Venn diagrams, and also we are going to look at solving problems based on that. I'm going to pick the color. Now here we have in purple the A. So A is there, which is a subset of the universal set. Or we call it whole set. It's everything. Now if you are in A, so you are in this particular region, but what happens if you go outside? So let me pick another color. In this color, the one orange that I'm going to represent is not in A. Well, as you thought, it's in fact not A. Or rather we call this one complement of A. Denoted by A dash, the notation wise. Righty, now we have the sets here which I discussed in my earlier video. In our discussion, I have given you different regions. We are going to look at how we write this one using so-called the complement of any set, and also these two, intersection and also union. Intersection mean what is in common, union mean in either. So you put them together, like you unite. It could be either. Let's have a look at the first one. Very first one, the two subsets A and B, they don't intersect, which means we have to write there is no common region in between both of them. That means if I look at the intersection, it will be empty. There's nothing. So the way we represent this one in notations, intersection we use upside down U. For the union, you use the U, that symbol. Not like U, it's just without that line underneath. So it's another symbol that we use in mathematics. So what do we write here? We write A intersection B. I have to tell the listener where there is no element in common, which means we have to say using that particular symbol called pi. That's a Greek symbol in a Greek alphabet. So we use that one whenever you see this particular symbol, which means they do not intersect in here in this case. But if you see this one as in a set, it's an empty set. So it's empty. That's nothing in there. That's what it is. Well, obviously the second one is represented. Let me get the proper color. Oops. So that's A intersection B. So what is in common for both A and a B? Well, here we go. The third one, we have A as well as in B or both. So we call this one a union. A union B. So this is called the union of A and B. Now the fourth one is called just in the B, but you can't go into the A region here. Though you have the B here, it is just in here. So we call this one B only. B only. It's only B. So how do I write this? Okay, you have to be in B, the set B, but you got to be outside of it. So it's A intersection B. Similar one down in the left here. It's in A but not in B. Therefore we say, okay, B outside, you're outside the B, complement of B and in A. So that's where we get this particular region. Okay, now having a look at this one, number 6. We have everything colored outside either of the A or B. So what is A or B? That's our union, isn't it? One on the left here, top left, number 3. So we simply write down, well, it's A union B. You got to be not in that, which means the complement. We call it dash, A union B dash. Now moving on, the seventh one is simply you either in only B or only A. Simply number 4, this one, or 5 on the left. Simply putting them together as a union. Now we are going to write it's either you in A, that's your only A, then you write down outside A and B, which means only B. You say either. It could be on the left hand side here or the right hand side there, so you put union. Well, the final one is, well, you can see the uncolored area is A intersection B. Well, you are saying you colored outside of that one, then it should be not A intersection B or complement of A intersection B. Well, we looked at a lot of regions here involving just 2 subsets. A good sort of like an example, or if you free, when you get a free time, just quickly draw maybe 3 subsets intersecting each other. Try to find how many different shaded areas you can form in there. I can guarantee there are many, and we can work through that one in our next lesson. Well, now we are going to form a relationship between the number of elements in 2 sets. Well, in this case, 2 subsets of our universal set. Let me do an example with you. Let's say N1 is 7, N2 is 4, N3 is 10. Okay, well, now if you look at A has both of these. Okay, let me pull another color. So A. So we call it NA, number of elements A is 7 plus 4, 11. Then I can say B. B is N2 and N3. So NB is 14 now. Now, by the way, NA is the notation to write down the number of elements in that particular set. So N means number of elements. Now, if I look at the union is A union B, simply adding N1, N2, N3. So 7, 4, and then 10. So what do we get? Should get 21. But if we add the NA and NB, what do we get? We get, in fact, 25. Ooh, that's a big mistake, isn't it? That's incorrect. We know that it's only N1, N2, N3. What has happened? Well, the one in N2, which is our repetition, the value in intersection been repeated. So it's in A as well as in B. Hence, we have to take away that from the addition here to get down to our appropriate value. Now we try to connect this into more theory form. Let's say NA is N1 plus N2, and then NB N2 plus N3. Now if I look at union, is simply N1, N2, and N3 only. Now how do you figure out to connect NA and NB with that one? Well, let's write N1 and N2, and then we have N2 and N3. I can see just one of the N2s being repeated, so you simply take away N2, and I know that this is NA, this is NB. I'm color coding so that you can clearly see that. And the one on the left was NA union B, the number of elements in union. Now, what do we have to do? We got to take away N2. N2 is A and B. We know how to write that. A intersection B. There you go. So we form the theory part here. If we've been given 2 subsets. That's how it works. Obviously, if there is no intersection between A and a B, that means simply that's not there. Well, then the equation becomes NA plus NB because there is nothing in common. So that's simply understood in there. Well, let's go down to one of the examples to work through now. Well, in this Venn diagram, we've been given those who likes athletics or cricket. So I put T for track and field for athletics and C for cricket. They are the numbers given. Now we are looking at how many students are like athletics. Well, what is athletics? That's in track and field. Just in here, 15 plus 6, we can say NT. 15 plus 6, 21. And then like cricket, that's in here, 6 plus 9, that's NC. Well, let me make it a little bit bigger, nice and bigger. NC, 6 plus 9 is 15. Like both the sports, that means the union. In this case, actually, it doesn't say either. So both has to be and. So in this case, it's and. So you got to be very careful when you look into these wordings. Both mean and, just in here. So we are writing down N, T, and C. So that's only 6. Excuse me. Now we are looking at only athletics. Only athletics mean it's number of in T but not in C. So that's just 15. Likewise, we have only cricket. So only cricket is just in the cricket area. We have not in T but in C. So that's 9 of them. Okay, the next one is like only one sport. One sport mean either athletics or cricket. So simply adding these two together to get that one. That gives you 24. Like neither. So the ones who doesn't like, maybe they like soccer or something else, rugby. It's only 4 outside there. We are right in that one, as in sets. It's whoever doesn't like. It's not the union of these two. So it's outside there. Well, we discuss one example. We'll look at the other example. So in this case, exactly the similar example that I pull in my other video lesson. We are going to look at who's involving in dancing and singing. Here you can see S for singing and D for dancing. The dancing now is a subset of singing. Well, let me get that color. Well, it's a subset, it's inside. Now let's have a look at who likes singing or involving in singing. Those who only singing as well as doing dancing too, because they singing as well. Hence we have 10 plus 8. This is NS, 18. And dancing, that's ND. We have 10 of them. Both subjects. Now they involve in both of them. Simply those who are dancing because they sing as well. Hence the intersection D and S becomes just the D. Hence 10. Only singing. Only singing is whoever doesn't dance but sing. It's outside this green area circle. It's 8 there. So we can write down those who like singing but not dancing. 8 of them. Well, only dancing, we have a problem. Whoever dance, sing too. Hence, we have none. We can say number of in dancing, not in singing, is 0. What do we find here? We find the null set. There is no one who doesn't sing but dance. Now, neither mean it could be just art or drama. something like that. There are 6, so we can say number of outside singing or dancing outside will be 6 of them. Well, okay, ladies and gents, හොඳයි දුවේ පුතේ, අපි මේ ගණන් ටික සාකච්ඡා කරා. මම හිතනවා ඔයගලන්ට මේ ටික හොඳට පැහැදිලි වෙන්න ඇති කියලා. Again, as I have asked, you can simply email me if you got questions. I'm happy to do screencasting. This is called screencasting. And I know this will be little quicker, marginally quicker than my first video that I did for the sets. But if you want me to do more explanations, or if you need to clarify more things on these, please email me. I'm happy to do a screencast and explain more and more. That's what I like. Anyway, I'll catch you on in the next video. Until then, yeah, thanks for watching, and look after yourself. Teruwan saranai.